Hello everyone, welcome to Chemspires. Now we'll look into the question 1.34. A welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives 3.38 grams carbon dioxide, 0.690 grams water and no other products. A volume of 10 liter measured at SCP of the welding gas is found to weigh 11.6 grams. Calculate the empirical formula, molar mass of gas and molecular formula. So first of all, let us find out the empirical formula. So how to do it? In the question, amount of carbon dioxide and amount of water produced is given. So first let us write 1 mole of carbon dioxide gives how much moles of carbon. So 1 mole of carbon dioxide contains 12 grams of carbon. How do we know that? We know from the molar mass, that is atomic mass, sum of the atomic mass. We can say that carbon's atomic mass is 12 and oxygen is 2 into 16. So in carbon dioxide, contribution of carbon is 12 grams. And molar mass of carbon dioxide is 44 grams. 1 mole of carbon dioxide can be written as molar mass, that is 44 grams of carbon dioxide, which gives 12 grams of carbon. So 1 gram of carbon dioxide will be 12 by 44. Taking 44 to the left side, so right side, we'll take it to the denominator. So 12 by 44 grams of carbon. So 1 gram of carbon dioxide will be 12 by 44, which is nothing but 0.2727 grams of carbon. So 1 gram of carbon dioxide gives 0.2727 grams of carbon. And in the question it is given 3.38 grams of carbon dioxide is produced. So 3.38 grams means multiply 3.38 into 0.2727 grams. So the value will be equal to 0.9218 grams of carbon. So 3.38 grams of carbon dioxide has 0.9218 grams of carbon in it. The same way let us find for water too. So 1 mole of water H2O contains how much amount of water, how much amount of hydrogen? 2 grams of hydrogen, because 2 into 1, that is atomic mass of hydrogen. So 2 into 1, that is 2 grams of hydrogen is present in water. Molar mass of water is 18 grams. So 18 grams of water gives 2 grams of hydrogen. Then 1 gram of water will be, take this 18 to the denominator of the right hand side, so 2 by 18 grams of hydrogen, which will be equal to 0.1111 grams of hydrogen. But in question 0.69 grams of water is given, so we shall write 0.69 grams of water gives 0.69 into this 0.1111 grams of hydrogen. So on multiplying, we will get the answer as 0.0766 grams of hydrogen. Sorry, I have written as water. It's not water, it is hydrogen. So here also you will change this H2O into hydrogen. So since only carbon and hydrogen are present, sorry, water will not come, hydrogen. So only carbon and hydrogen are present. 0.9218 grams plus 0.0766 grams. It will be the total mass. So it will be equal to, on adding we will get 0.9984 grams. So this is the total mass of this welding fuel gas given in the question. We have found out the carbon and hydrogen, and then we have found out the mass of the total compound. Now let us find out the percentage of carbon and hydrogen present in the sample. So the percentage of carbon will be the mass of carbon by total mass into 100. So the calculated mass of carbon is 0.9218 grams, and the total mass we have calculated just before, that is 0.9984 grams. So on dividing these both, and also we should multiply by 100, and on solving this one we'll get the answer as 92.3% as the answer. Likewise, percentage of hydrogen is also to be calculated. So same way, we'll write the calculated mass of the hydrogen, that is 0.766 grams, and the total mass is 0.9984, which we have calculated just before, into 100. On solving this, we'll get 7.7%. So on adding these, we'll get 100. So our answer is right. So we can proceed. The next step is to calculate the number of moles of carbon and hydrogen both separately. So number of moles formula is mass by molar mass. So for calculating the number of moles of carbon, we'll use the mass that is already calculated one, which I have marked it in the box. And the same way, number of moles of hydrogen will be mass of hydrogen by molar mass. So number of moles of carbon will be 0.9218 grams divided by 12 grams per mole. 12 is the molar mass of carbon. And for hydrogen, same way, 0.076 grams by 1 gram, which is the mass of hydrogen, molar mass of hydrogen. Gram gets cancelled, and we'll get the final answer of number of moles of carbon will be 0.0768 moles, and likewise for number of moles of hydrogen we'll get 0.0766 moles. So if we see, both the number of moles are almost same. Let us now take the ratio of the number of moles of carbon and number of moles of hydrogen. So what will be the ratio? Ratio of number of moles of carbon is to number of moles of hydrogen will be 0.0768 is to 0.0766, which is almost 1:1 ratio. So we can say that carbon and hydrogen are present in 1:1 ratio. That means if carbon is present in a particular amount, hydrogen is also present in the same particular amount. So we can write the empirical formula as C1H1. The 1 and 1 written in the subscript is nothing but the ratio of each element present in the sample. So C1H1 can also be written as CH. So empirical formula we have calculated. Now we will calculate the molar mass of gas, which is the second subdivision. So to calculate the molar mass of the gas, in the question there is given a hint, which is a volume of 10 liters measured at STP of the welding gas is found to be weighing 11.6 grams. So 10 liter of gas at STP is given as 11.6 grams. Then 1 liter of gas at STP will be 11.6 by 10, because we are taking the 10 to the right hand side, so we will take it in the denominator. So 22.4 liters of gas will be 22.4 into 11.6 by 10. Why 22.4? Because 22.4 liters of gas is nothing but 1 mole of the gas. So we'll calculate 22.4 into 11.6 by 10. The value comes out to be 25.984, which is almost equal to 26 grams. So the molar mass of the gas is calculated to be 26 grams. Now molecular formula will be empirical formula, the whole subscript of a particular number n, we can denote it as n, and to calculate the n there is a formula which is molar mass of gas divided by empirical mass which is found out. That is empirical formula mass. So empirical formula mass is nothing but CH. So 1 into 12 plus 1 into 1, which is 13 grams, and molar mass of gas is found out as 26. So 26 grams by 13 grams will be equal to 2. So N will be 2. So molecular formula is CH the whole subscript of 2, which is equal to CH the whole twice. It can also be written as C2H2, taking the 2 inside. And this C2H2 gas is called as ethylene gas, which is CH triple bond CH. This is just for your information.